So today we're going to be discussing about proportional and non-proportional relationships. Inside your notes, I would label it as 1.4 proportional and non-proportional relationships. The essential question, how can you show that two objects are proportional? That will be answered by the end of this lesson. Vocabulary are the words proportional, non-proportional, and equivalent ratios. So real world link, pizza party. Miss Cochran is planning a year-end pizza party for her students. Ace Pizza offers free delivery and charges $8 per medium pizza. Step 1. Complete the table to determine the cost for different numbers of pizzas ordered. So it costs $8 for one pizza. That's that information right there. So if you were to buy two pizzas, that's going to cost you $16. Yep. Three pizzas is going to cost you $24. Four pizzas is 32, and five pizzas will be a total of 40. Each time I multiplied the number of pizzas by 8 to get the total cost. Sorry, change that to a 6. It looks like a 6. So number 2, for each number of pizzas, fill in the boxes to write the relationship of the cost and number of pizzas as a ratio in simplest form. A 16 halves. Well, the denominator is reduced from 2 to 1, so I divide the denominator by 2. So I need to divide the numerator by 2. 16 divided by 2 gives me 8. 24 thirds, you divide the numerator and denominator by 3. That leaves you with 8 divided by 1. 32 divided by 4. That will be reduced down to 8 divided by 1. Because you divide the numerator and denominator by 4. The last ratio is going to be 40 divided by 5, which reduces down to 8 divided by 1, because I divided the numerator and denominator by 5. Number 3, what do you notice about the simplified ratios? Well, we have 8 divided by 1, 8 divided by 1, 8 divided by 1, and 8 divided by 1. So the ratio is 8 to 1. So the ratios are equal. Each ratio is equal to 8. Let's continue. On the next page, page 34, we're going to identify proportional relationships. Here is one of our vocabulary words. Two quantities are proportional if they have a constant ratio or unit rates. For relationships in which the ratio is not constant, the two quantities are non-proportional. In the pizza example on the previous page, the cost of an order is proportional to the number of pizzas ordered, because all of them reduce down to $8 per pizza. All the ratios above are equivalent ratios because they all have the same value. So when they're referring to the ratios above, these ratios that I'm highlighting right now are all equivalent ratios because they all equal each other. So let's look at an example. Number 1, Andrew earns $18 per hour for mowing lawns. Is the amount of money he earns proportional to the number of hours he spends mowing? Explain. So to find the amount of money he earns for working a different number of hours, make a table to show these amounts. So the top portion is the earnings in dollars, and the bottom portion is the time in hours. So if he works for 1 hour, he gets paid $18. 2 hours is 36. 3 hours is 54. 4 hours is 72. For each number of hours worked, write the relationship of the amount he earned and hour as a ratio in simplest form. So 18 divided by 1 is 18. 36 divided by 2 reduces down to 18. 54 divided by 3 reduces to 18. 72 divided by 4 reduces to 18. So each one of those is information taken from the table above. All of the ratios between the two quantities can be simplified to 18. The amount of money he earns is proportional. I'm going to highlight that. Proportional to the number of hours he spends mowing. Got it? So we're going to do this problem down here to find out. Letter A. At Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at the school proportional to the number of teachers? And explain your reasoning. So here I'm going to take the information of 48 students to 2 teachers. I'm going to find the unit rate. I want to know how many students per 1 teacher. To get from 2 to 1, I had to divide by 2. Whatever I do the denominator, I want to do the numerator. So 48 divided by 2 gives me 24 students. So the ratio of students to teachers is constant. I'm going to write that down over to the left. The ratio of students to teachers is constant. The ratio is 24 to 1, or 24. So since the ratio is constant, the number of students, not is students, the number of students is proportional to the number of teachers. All right, we're going to go ahead and continue on to the next example. Example 2. We have Uptown tickets that charges $7 per baseball game ticket plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? And explain. So 1 ticket order costs $10. 2 ordered tickets are 17, 3 are 24, 4 are 31. So for each number of tickets, write the relationship of the cost and number of tickets as a ratio in simplest form. So we'll take 10 tickets divided by, I'm sorry, not 10 tickets, $10 for 1 ticket, which reduces down to 10. Then we're going to take 17 tickets. Oh my gosh. Sorry. $17 for 2 tickets. So that's 8 and 5/10. $24 for 3 tickets reduces down to 8. $31 for 4 tickets is $7.75. If you take a look at all of the reduced fractions, none of these ratios equal the same. So since the ratios of the two quantities are not the same, the cost of the order is not proportional to the number of tickets ordered. So let's take a peek at the next one. Example 3. You can use the recipe shown to make a fruit punch. Is the amount of sugar used proportional to the amount of mix used? And explain. First, we want to find the amount of sugar and mix needed for different numbers of batches. Make a table to help you solve. Here we have the cup of sugar and the envelopes of mix. So according to the recipe over here, I'm going to zoom in on it. We want half a cup of sugar, 1 envelope of water, and 2 quarts. I'm sorry, 1 envelope of mix and 2 quarts of water. So for every half cup of sugar, we want 1 envelope of mix. So if I have half a cup, that's 1 envelope. A full cup is 2 envelopes. 1.5 cups is 3 envelopes. 2 cups of sugar is 4 envelopes. So for each number of cups of sugar, write the relationship of the cups and number of envelopes of mix as a ratio in simplest form. So if we have half a cup of sugar to 1 thing of mix, that reduces down to 5/10. If we have 1 cup of sugar to 1 envelope of mix, that reduces down to 5/10. 1 1/2 cups of sugar to 3 envelopes of mix also reduces down to 5/10. Sorry. Then if we have 2 cups of sugar and 4 envelopes of mix, that also reduces down to 5/10. So when we take a look at all of our ratios, they all reduce down to the same amount. So that means all the ratios between the two quantities can be simplified to 5/10. The amount of mix used is proportional to the amount of sugar used. Got it? Let's do this problem to find out. Letter B. At the beginning of the year, Isabel had $120 in the bank. Each week, she deposits another $20. Is her account balance proportional to the number of weeks of deposits? We're going to use the table below to explain our reasoning. So she had $120. Each week, she deposits another $20. So I'm going to add this information here. We have $20 to begin with. Then we're going to add another 20. So that gives me $140. We're going to add 20. That's $160. I'm going to add 20, which is $180. So each week I'm adding $20. So to find out whether or not it is proportional to the number of weeks of deposit, this is going to be no. The weeks to account balance ratios, so the account balance ratios are not equal. So I can show that work with 140 divided by 1, which reduces to 140. Then I can take 160 and divide it by 2, and that's going to give me 80. And then I can also take 180 divided by 3, and that's going to give me 60. So when I take my ratios, these three are not proportional because they are not equal. Let's continue. Example 4. The tables shown represent the number of pages Martin and Gabriel read over time. Which situation represents a proportional relationship between the time spent reading and the number of pages read? Explain. So we have Martin's reading on the left, and we have Gabriel's reading on the right. So for Martin's reading, you can take the number of pages to the time. So below they have 2/5, 4/10, oops, and 6/15. 4/10 can be reduced down to 2/5, as well as 6/15 being reduced down to 2/5. Then if we take a look at Gabriel's, his is 3/5, 4/10, and 7/15. So 4/10 can reduce down to 2/5. Gabriel does not have a proportional relationship because all three of the ratios do not reduce down to the same number. So all the ratios between Martin's quantities are 2/5. So Martin's reading rate represents a proportional relationship. Okay, so now you're going to go ahead and you're going to try the problems yourself.